Good morning. Today we are going to see the problems from university examination. Now, whatever portion we have studied till this, so in this, if you will see, we can solve two questions, means we can have 10 marks from this. And second part of this, that is application of differential equation to civil engineering. That part is little bit vast, so I have not considered this. So after this, we will go with simultaneous equation. That is simultaneous equations and different methods we are going to use. That is to solve the equations of system, or then we have that is different equations that we will go. We have different methods, that is Rangakuta method, Cholesky method, Gauss-Jordan method. So to solve equations, we will be with that method. Now we will go with first problem, that is x square d2y by dx square minus x dy by dx minus 3y equal to x square log x. Now you can see this, in this we have this x square. So these coefficients, you can see we have variable, and therefore we have to go, that is for Cauchy's equation or Cauchy's method or Euler's method to solve this. So we have to make first differential equation with constant coefficient, and for that one we have to put z, that is equal to log x, and then from this we will get, that is x equal to e to the power z, and we have x square, so this is equal to e to the power 2z. Then we have to substitute x square d2y by dx square. Now you have to see video that is related with Cauchy's equation. So equal to d in bracket d minus 1 into y, and x dy by dx, we have dy. So we will substitute these values, and from this we will get equation, that is d into d minus 1 y minus dy minus 3y, that is equal to x square is e to the power 2z and log x is z. Then we will take d outside, sorry, y outside, and then we have d in bracket d minus 1 minus d minus 3 into y equal to e to the power 2z into z. And when we will solve this, we have d square minus d minus 3 into y, which is equal to e to the power 2z into z. From this we will get d square minus 2d minus 3 into y, and that is equal to e to the power 2z into z. Now we have to find first complementary function, and for complementary function we have to write auxiliary equation, and we have auxiliary equation m square minus 2m minus 3 equal to 0, and we will get root of this m minus 3 m plus 1, and that is equal to 0, and from this we will get m plus 1 equal to 0. Therefore m1 equal to minus 1 and m minus 3 equal to 0. So we have m2 equal to 3. And knowing this, we can find complementary function yc equal to c1 e raised to minus x plus c2 e raised to 3x. So this is complementary function. And then we will go for auxiliary, for particular integral. So x square we have to put at e to the power 2z, and log x we have z. And then we will have particular integral. So we have particular integral, particular integral. And in this particular integral, we have yp is equal to 1 upon d square minus 2d minus 3. So d square minus 2d minus 3 into e to the power 2z into z. E to the power 2z we can take outside. So e to the power 2z, and in that case we will get d as d plus 2 whole square minus 2 into d plus 2 minus 3 into z. And then from this we will get e to the power 2z into 1 upon, now solve this, d square plus 4d plus 4 minus 2d minus 4 minus 3 into z. So this minus 4 gets cancelled. 4d minus 2d, so it becomes 2d. So we are equal to e to the power 2z into 1 upon d square plus 2d minus 3 into z. So we have to make it in 1 plus or 1 minus x to the power minus 1. So we will take minus 3 common. So minus e to the power 2z upon 3 in bracket 1 plus. Now I am writing directly, you have to go to basic video of this. So d square, sorry, this will be 1 minus d square plus 2d upon 3 and to the power minus 1 into z. Because this d square plus 2d minus 3, if I will take minus 3 outside, then we have d square plus 2d upon 3. This will be with minus sign plus 1. Or we can write it as minus 3 in bracket 1 minus d square plus 2d upon 3, and then we have to the power minus 1. Then we have both minus. So we have all terms plus. So minus e to the power 2z upon 3 in bracket 1 plus. Now we need not require to go for square because we have z. And we know d of z is 1. D square of z is also 0. So we do not have d square term also. We can directly write that is 1 plus 2d upon 3, and that is into z. And now if we will make it separate, minus e to the power 2z upon 3 in bracket z plus 2 by 3 d of z. And then if we will solve this, then we will have this as minus e to the power 2z upon 3. Then we have z plus 2 by 3, and derivative of z with respect to z is 1. Now substitute values of z. So we know we have z equal to e to the power 2z. We have seen we have e to the power 2z, that is equal to x square. So we will substitute this value and z equal to log x. So we will put these values. So we have minus x square. So minus x square upon 3 in bracket z is log x plus 2 by 3. And if we will take 3 again outside, then we have this as minus x square by 9 in bracket 3 log x plus 2. And this is my value of yp. And therefore we will write yc plus yp, and then we have this as solution y, that is equal to yc plus yp. So y is equal to yc plus yp And then we have solution y is equal to yc, we have c1 e to the power minus x plus c2 e to the power 3x minus x square by 9 in bracket 3 log x plus 2. So we have 3 log x plus 2. So just check it. So x square by 9, 3 log x plus 2. And then we have c1 e raised to minus x plus c2 e raised to 3x. So we have, this is solution for the first problem. We are not going to be all three problems in one video, because otherwise that video becomes lengthy. So we will have this as first problem, so you can see this. So we have first problem in this video. So now we will go in the second video, second problem of this, that is d2y by dx square plus y equal to x sin x by method of variation. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.